Welcome to IQ Tuition Center. Okay, so today we are doing a continuation on binomial expansions. So on the previous video we did general expansion of binomial expressions, how to find the middle term, how to find the independent term of x, and how to find also the positions of a term in a given sequence. So you can check out that video and watch. So today we are doing a continuation on binomial theorem. Binomial theorem. So this binomial theorem is a theorem which is used to expand binomial expansions. So this theorem, if you have a binomial expansion in this form, 1 plus x raised to the power n, okay? So if a binomial expansion is in that form, okay, so this can be given as 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x to the power 3. It can continue going like that. So this is what we call binomial theorem, as long as your binomial expansion is in this form. Okay? So now when you are given something like this, what does n stand for? So n is just the power. Okay, n is just the power of that binomial expansion. Okay, 1 is the first term, x is the second term of the binomial expansion. So now this one I've just given you up to 1, 2, 3, the fourth term there. Okay, so now this theorem here can be used to expand 1 when the power is negative. Okay, so this theorem can be used. So we are saying that 1, it can be used to expand an expression. Let's put to expand a binomial expression with a power of maybe a negative power there, a negative power. Okay, so when the power is negative there, you can use binomial theorem to expand. Maybe when the power there is a fraction or just an integer. Okay, negative or positive number there. Okay, so now let's put an example here. So now we are getting this example from a Deveta paper. Let's say we are given this expression here. Let's say we are given that expand, this is the first question, expand square root of 1 plus 3x, okay, square root of 1 plus 3x in ascending powers of x up to the fourth term, okay, up to the fourth term. Hence, find an approximation for square root of 1.08. Square root of 1.08. So that's the question which we are given. That's the question which we are given here. Okay? So now we need to expand this binomial expression in ascending. So there is a condition here in ascending powers of x. So it means the powers on x will be increasing. Okay? So like in this expression here where there is just one, it's more like you have 1x to the power 0. This is x to the power 1, x to the power 2, x to the power 3. So this theorem here is the best used on that question here. Okay? So we have a square root. Okay? We are given square root of 1 plus 3x. Square root of 1 plus 3x. You need to know that a square root is same as half. So it means this expression is equal to 1 plus 3x, everything raised to the power half. Okay? Because square root is same as half. Okay? So now we can compare that this expression here is in this form because we have 1 here, okay, plus and x. This x is the whole of this expression here. Okay? So now, then the power, the n from the theorem there is 1/2. Okay? So now, what are we going to do? To expand this one here, because we are saying that 1 plus 3x raised to the power 1/2 will be equal to, you get 1 the way it is. Okay? So this is 1 plus, okay, n is the power. Okay, n is the power. In this case, power is 1/2. So I get 1/2. Okay, times while there is x. Remember, we're not just getting x, but we are getting the whole of this, which is 3x plus or 3x. So we're getting 3x here. Okay, then we'll go to the next one, which is plus. Okay, since here they want up to the fourth term, so we'll need about 4 terms in this expansion here. So next is we are here. So n is 1/2. So I think that 1/2 inside here is 1/2 minus 1. Okay, over 2 factorial. Okay, while there is x, we need to be careful. Remember, we are getting the whole of this. Now, since here x is squared, what we put here should also be squared. So this 3x should be squared like this. Plus, next we are here. So we are getting 1/2. Inside the brackets, it's 1/2 minus 1. Here it is 1/2 minus 2. Okay, over 3 factorial. Then here, this is raised to the power 3. So 3x will be raised to the power 3 like this. And when you check it, this is our first term, second, third, and fourth. So we'll end there. Okay? So now let's start reducing. Don't end there. You reduce the expression there. Okay? So this one can't be reduced. We get it the way it is 1. Then when you multiply there, you find that we get plus that is 3/2x. Okay? Then there, inside the brackets there, you need to be careful now. Okay? What is this 2 factorial? So 2 factorial is just same as 2 times 1. So in short, 2 factorial is equal to 2. Even when you press on the calculator, you get what? 2. So now, what are we saying here? On top there we have plus. Okay, let us write half the way it is. That is 1/2. When we subtract half minus 1, you get negative 1/2. Okay, over 2 factorial. Then here, you need to bear in mind that this squared is on both 3 and x. So what are we saying here? This is 3 to the power 2. You get it. So here there is times. You get what? 9. Then x to the power 2 like that. Okay? Plus, here you have 1/2, this one here. Inside the brackets you have negative 1/2. Okay? There, what do you get when you say half minus 2? Let's use it again so that we move fast. So, when you subtract 1/2, you you lessen it by 2, you get negative 3 over 2. So here we are getting negative 3 over 2, okay, over 3 factorial. So we are doing the same again. This 3 factorial is same as 3 times 2 times 1. So this one gives us what? 6. So in short here, where there is 3 factorial now, we'll substitute with what? 6. Again here you need to be careful, okay? 3, this 3 is on both 3 and x. So 3 to the power 3, we are getting 27, then x to the power what? To the power 3, like that. Okay? So now, this is equal to 1 plus, okay? We are writing that one the way it is, which is 3 over 2x, okay? When you multiply those, you get, that is negative 1 over 4, okay? So where there is 2 factorial, we are putting 2. We've discussed there on how we are getting 2, okay? This is divided by what? 2 times 9x to the power 2, okay? Here when you multiply those, so plus, there when you multiply, you get now negative 1 over 4, okay? This will multiply negative 3 over 2, okay? Over 6 times 27x to the power 3. Okay? So that's what we are getting. So let us continue reducing. There. So when we say here, so this one will still give us 1 plus 3 over 2x. Okay? So this negative 1 over 4 divide 2 is just same as this is just same as negative 1 over 4 times 1 over 2. So this one gives us, so here we have, when you punch everything here, you get negative 1 over 8 times 9x to the power 2. Okay? Then what happens when you multiply those? When you multiply this negative times negative, you get it positive. Okay, so 1 times 3, that is 3 over, that is 4 times 2 is 8. Then here you have times 27x to the power 3. Everything is divided by what? By 6. Okay? Everything is divided by 6 there. So now, here when you reach here, what are we saying? Let us write this the way it is. So 1 plus 3 over 2x, okay? So when you multiply those, you get now negative 9 over 8x squared. So I want to reduce it. So when we say 27 times, so 27 times 3, 27 times 3 is giving us that one. So we divide. We divide 8 there, so we are getting, so on top, so when we multiply, this is more like over 1 there, so 27 times 3, so 27 times 3 is giving me, 27 times 3, we are getting 81, so on top we get plus 81 over 8, okay? X to the power 3, everything divided by what? By 6. Again, you can reduce there. So now, 81 divides 8, we get 10.8. Again, this same one divides 6, we get something like this, 27 over 16. So when you punch all this, you get. So the final answer, the general expansion for this one up to the 4th term there, we get. So what are we saying? This 1 plus 3x raised to the power 1 over 2 is equal to 1 plus 3 over 2x minus 9 over 8x squared plus 27 over 16x to the power 3. Okay, so we end there. So this is the expansion, okay? This is the expansion of this binomial expression in ascending powers of x. When you check here, the values of in terms of the powers are increasing. This is 1 here, 2, 3. Of course, here it goes x to the power 0, which we cannot show there, okay? So you end there. Now, the other concept again, rather the other question is, after you expand, this is how you answer now a derivative question. After you expand like this, they have asked you now to hence find an approximation for square root of 1.08. You don't have to punch on the calculator. You use the same expansion there to find the answer for square root of 1.08. What are we going to do? So what are we doing here? Okay? What is now the square root of 1.08 without using a calculator direct? What is the square root of 1.08? So now what are we going to do? Okay, what are we going to do? We have this expression here which we have expanded. We know the expansion of 1 plus 3x. Okay? We know the expansion of what? This square root of 1 plus what? 3x. So now what are we doing here? Let us try to write this one in this form here. Okay? You need to know that this square root of 1.08 is same as square root of 1. Okay? 1. So this 1.08 is same as 1 plus 0.08. Okay? This 1.08 is same as 1 plus 0.08. Okay? So now, since we've written this one in that form, what are we saying? What are we saying? Let us try now to equate this one to that one. So what are we saying? This is now square root of 1 plus 0.08 is equal to now square root of 1 plus 3x. Okay? 1 plus what? 3x. So you can see that we have 1 here, also have 1, which means that this 0.08 is equal to 3x. So now we need to find the value of x, so that we substitute there where there is x, we put whatever value there we get. So what are we saying? This now is equal to that one. So 0.08 is equal to 3 what? X. We want to find the value of x. So you divide what? 3 here, even there, 3. So like this one and that one goes. So x is equal to, when we divide 3 into 0.08. So 0.08 divide 3, we are getting 0.02666. Okay, the 6's are recurring there, so we can just get them up to that point there. Okay, so since we know the value of x and this is equal to that one, now we already have the expansion for this one, so we can substitute where there is x, you put that. By doing that, we have found the square root of the square root of 1.08. So what are we going to do? I'll just erase this same part here. Okay, since we know the value of x, okay, let us write it here. The value of x here is 0.0267. You can get maybe round it off, at least you get those figures. Okay, so now, the square root now, square root of 1.08 would be equal to, we are going to substitute. So we'll start with 1, okay, plus where there is x, so that is 3 over 2. Where there is x, we are putting now 0.0267, okay? We are going to the next one, which is minus 9 over 8, okay? We are substituting that expression there. So where there is x, in this case 0.0267 raised to the power 2, okay, plus 27 over 6, rather 16. This is 0.0227, 267 raised to the power 3, like that. So now let us start reducing. Let us start reducing here. So this is, let's get one negatives. This is 1. So this is 1 plus, of course that is 1.5. So let us say this is 1.5. So 1.5 times 0.0267. Okay, so this one 1.5 times 0.0267. So this one is giving me 0.0405. Okay, then before you multiply this with 9 over 8, you need to square it. So what are we saying? We're saying that 0.0269, okay, you square this one, you get, so here what are we saying? This is 9 over 8 times 7.1289 times 10 to the power -4. So it is in standard form, okay? So plus 27 over 16, okay? Again, let's find the cubic of this value of x. So 0.0267 raised to the power 3. So it's giving us 1.9034 times 10 to the power -6. So now we are going to multiply this number by it. We are getting this one the way it is. So 1 plus, okay, 0.04005. Okay, so now let us multiply this one here first. So what is 9 over 8? Okay, times, okay, times 7.1289 exponential -4. Okay, so this one is giving us, when you multiply everything, you get now minus 8.02000125 times 10 to the power -4. Okay? Again, let us multiply this one. Let us first divide 27 divide 16. Okay? We'll get 1.6. So here you are getting 1.68. So times that number there. So this answer here times 1.9034 exponential -6. So we are getting now plus, okay, because here it's plus 3.21198 times 10 to the power -6. So now what we are going to do here, we'll add the whole these numbers given here, okay? So you need to write nicely. So square root of 1.08 is equal to, let's try to add over what we have found there. So 1 plus 0.04005, okay, minus 8.0200125 exponential -4, okay? Again here plus 3.21198 exponential -6, okay? So this one is giving me, all this when you add, we are getting 1.039. Okay, so this is the square root of 1.08. Let us try now its own calculator direct. So square root of 1.08, okay, is giving 1.039 and some numbers there. Okay, so we are correct. So this is how you find now such questions when they ask you. Okay, so this is basically, this is how you work with binomial theorem. Okay, this is how you work with binomial theorem. The other point, just in case they ask you something like this. Okay, There are some questions which they will ask you. For example, whether they ask you to say expand maybe 1 over 1 plus maybe 4x raised to the power 3. When you're given something like that, okay, when you expanded that one up to maybe up to the third term there, okay, when you're given something like this, don't get confused, okay. What you just need to know is that this is same as, okay, this is same as 1 plus 4x raised to the power negative 3. Okay, when this one goes up to a negative, okay, the power of a negative. Once you reach here now, you can apply the binomial theorem, whereby this is your n, this is your x, and that one is as in that form there. Okay, so for now we end here, and more questions will be uploaded on binomial theorem.